Now I will explain to you about introduction of growth and decay. Growth and decay indicate the direction in which a quantity is changing. If something grows, it signifies that its value is increasing. If something is decaying, it signifies that a value is declining. Second, exponential growth is useful in analyzing bacterial development, population expansion, and money growth schemes. For exponential decay method, it may be used to determine food degradation, half-life, and radioactive decay. And lastly, the concept of exponential growth and decay can be observed in numerous day-to-day scientific industrial activities. Next, I will tell you the reason we need to calculate population growth. First, to make better predictions about future changes in population size and growth rates. Second, to understand what causes changes in population size and growth rates. And lastly, to know how organisms interact with each other and with their environments. Next, we move to our problem statement. The number of population of a hamster initially has F number. At 6 months, a population of hamsters increased 8-fold. If the rate of growth is proportional to the number of population of hamsters at a present time, determine how long did it take for the population of the hamsters to triple. So, to solve this problem statement, the method that we use is applications of first-order differential equation, which is population growth. And the formula that we use is dn per dt equal to Kn, where K is a constant of proportionality and N is the number of population.
My name is Safia Balkis and I will be explaining the solution to our problem today. So to answer our question, we need to have the formula N equals to A e to the power of Kt. But where do we get that formula? So we'll get the formula from the differential equation dn over dt equals to Kn, where N is the number of population and K is a constant of proportionality. So firstly, we need to separate the variable into the same term. So dn over n, that is the n term, will be on the left side. So it will be equal to K dt. So the t term will be on the right side. So then we need to integrate both sides. It will be integrate dn over n equals to integrate K dt. So we will get ln n equals to Kt plus C. Next, we will be exponentiating both sides using the exponential rule. So we will get e to the power of ln n equals to e to the power of Kt plus C. So the term e to the power of ln n will equal to n. So n will equal to e to the power of Kt times e to the power of C. So the final equation or the general solution of growth population could be written as n equals to a e to the power of Kt, where a equals to e to the power of C. Let's move on to answering the question. So the formula is n equals to a e to the power of Kt. So based on the question, F represents the initial population of the hamsters. So the equation would be n open bracket 0 close bracket equals to e. So firstly, we need to find k. Based on the question, we know that in 6 months, the population of hamsters would increase 8-fold. So we would know that the t would be equal to 6 and the equation will be n open bracket 6 close bracket equals to 8a. We will substitute it into the formula. So 8a equals to a e to the power of 6k. It will be 8 equals to e to the power of 6k. So using the log rule and the exponential rule, the equation would be ln e to the power of 6k equals to ln 8. Then the term ln e to the power of 6k, we know that it will be 6k. So 6k will equal to ln 8. Then k would equal to ln 8 over 6. in the end, the K would equal to 0.3466. So we substitute the K into our formula, then it will be N equals to AE to the power of 0.3466T. So that is the general growth model. So, to recap the question, how long did it take for the population to triple? So based on the question, we need to find T, the time. So the equation would be N open bracket T close bracket equals to 3A. So 3A because the triple of the initial population. So we need to find the time, like how long did it take for it to triple the population. So we will substitute it into the formula, that is N equal to AE to the power of KT. So it will be 3A equals to AE to the power of 0.3466T. It will be 3 equals to E to the power of 0.3466T. So using the log n exponential rule, into the equation, it will be ln e to the power of 0.3466t equals to ln 3. So we know that the term ln e to the power of 0.3466t will be 0.3466t. So 0.3466t will equal to ln 3. So t will equal to ln 3 over 0.3466. In the end, we will get t equals to 3.1697. So, we shorten it. It will be t equals to 3.17 months. So we can conclude that it would take approximately 3.17 months for the population of hamsters to triple based on our calculation just now. For our conclusion, we conclude that the growth and decay application will benefit a lot in our daily life, such as we could monitor the bacteria population growth and the compound interest. For example, understanding exponential growth can help us appreciate how compound interest works in a savings account, allowing our money to grow over time. That's all for today. Thank you.